Okay, let's see the next question, question number 16. So in the question number 16, a glass of convex lens. So it means that refractive index of the glass, we'll consider it as N2, that is given 1.5, has a focal length of 8 cm when placed in air. So focal length of this one will be 8 cm. What will be the focal length when the lens is immersed in the water of refractive index? So here let's say N air is 1 and N water is considered as 1.33. It is given in the question. Okay, so we need to find the focal length in water. This is the focal length in air. Okay, so this kind of question can be solved using the lens maker's formula. Okay, so by lens maker's formula, now see, lens maker's formula is 1 by f is equal to n2 minus n1 upon n1 in bracket 1 by r1 minus 1 by r2. This is lens maker's formula. Okay, this is for the refractive index of lens, and this is the refractive index of surrounding medium. Okay, now if we are considering the 1 by f of air, then it will be n2 minus n of air upon n of air. Okay, and this will be 1 by r1 minus 1 by r2. So focal length in air is 8 cm, so this will be 1 by 8. This will be 1.5 minus 1 upon 1. This will be 1 by r1 minus 1 by r2. So 1 by 8 is equal to 0.5. 1 by r1 minus 1 by r2. So this will be equal to 1 by 8 is equal to, you can write it as 0.5, that will be 1 by 2 in bracket 1 by r1 minus 1 by r2. So 1 by r1 minus 1 by r2 will be equal to 1 by 4. So this is our first equation. Okay, using this one we can find out the length, focal length of lens in water. Okay, so let's see the next one. Again writing the formula for the water. So this will be equal to n2 minus n of water minus upon n of water. So this will be equal to 1 by r1 minus 1 by r2. Okay, so n2 will be 1.5 minus 1.33. This will be 1.33, and value of 1 by r1 minus 1 by r2 is equal to 1 by 4, that we have found it. Okay, let's solve this one. Okay, so writing 1.5 as 3 by 2, and this will be as 4 by 3 upon 4 by 3. Okay, solving this one. So this will be 1 by 6, 9 minus 8 by, and this will be 3 2s are 6. This will be 4 by 3 into 1 by 4. This will be 1s are and 2s are, taking 2 in the denominator. So 1 by 2 into 4 into 4. So 1 by f of water. So focal length of lens in water will be 32 centimeter. This is very important question. Okay, note this one. This is also an very important question. Okay, so option D is the correct one. So option D is the right answer. Okay, so now let's see the next question, 17. In the question 17, the radius of curvature of convex surface of thin plano-convex lens is 15 centimeter. So radius of curvature for the plano-convex lens is given. Let's say plano-convex lens like this. Okay, so radius of curvature for this will be 15 centimeter, and for this R2 will be equal to infinite. Okay, because as it is a plane surface, the radius of curvature will be infinite. The refractive index of the material is 1.6. So n is given, that is 1.6, and we need to calculate the focal length of the power of lens of this plano-convex lens. Okay, so let's first find the focal length using the lens maker's formula. So lens maker's formula is 1 by f is equal to n2 minus n1 upon n1, and this will be 1 by r1 minus 1 by r2. So this will be 1 by f is equal to 1.6 minus 1 upon 1. We are considering air in the surrounding medium. Okay, surrounding medium is air. This will be 1 by 15, and this will be minus of minus infinite. So this will turn out to be 0. So 1 by f is equal to 0.6 upon 15. So f is equal to 15 upon 0.6, so 6 into 10. So here the focal length will be equal to, this will be 3, and this will be 5, this will be 3, and this will be 5. So focal length is 25 centimeter. Now finding the power, P is equal to 100 by F in centimeter. So this will be 100 upon 25. So power of length will be plus 4 dioptry. Okay. So power of this planar convex lens will be plus 4 dioptry. Option D is correct answer. Okay. Okay, let's solve the question number 18. Okay, you can see the question number 18 in your screen. Now see in that, okay, a biconvex lens is given. R1 is equal to 40 centimeter and R2 is also 40 centimeter. Both the curvatures are same. We need to consider it as plus and this will be minus. Okay. The refractive index of the material is 1.65. We need to calculate the focal length. See, it is plus just because its curvature is on the right hand side, and this will be minus because its curvature in the left hand side. So by lens maker's formula, 1 by f equal to n2 minus n1 upon n1, and this will be 1 by r1 minus 1 by r2. So the value of n2 is 1.65 minus 1 upon 1 into 1 by 40 and minus plus, so this will be 1 by 40 again. So this will be 0.65 into 2 by 40. Okay, so the value of f will be, you can write it as 40 into 100 and 2 into 65. Okay, so now cancelling this 2, so this will be 2165. Dividing these two values, you will get 30.76. So it will be approximate equal to 31 centimeter. Okay. So option B is the correct answer in this one. That's all the question number 19 that you can see in your screen. Now see in the question 19, the focal length of lens is given as R and the refractive index of the material is given as 1.5. We need to determine the focal length in water. Okay. So how much time the focal length will get increase or decrease in water, that we need to find out. So applying the lens maker's formula, 1 by f equal to n2 minus n1 upon n1 in bracket 1 by r1 minus 1 by r2. So therefore this will be 1 by r is equal to 1.5 minus 1 upon 1, and this will be 1 by r1 minus 1 by r2. So 1 by r is equal to 0.5 into 1 by r1 minus 1 by r2. So from this we can get the value of 1 by r1 minus 1 by r2, and that will be equal to 2 by, giving it as equation 1. So now the surrounding medium will be water, so that will be 1.33, so you can take it as 4 by 3. So focal length in water, let's say it is f dash, so it will be 1.5 minus 1.5, you can write it as 3 by 2 minus 4 by 3 upon 4 by 3 into 1 by r1 minus 1 by r2. Okay, so this will be 1 by 6 and this will be 4 by 3. The value of this will be 2 by r. Okay, so 3 ones are and 2s are, and taking 2 in the denominator. So this will be 1 by 8 into 2 by r. Okay, so 1 by f dash. So therefore 1 by f dash is equal to, we are having 1 by 8 into 2 by r. So cancelling this one, f dash will be equal to 4r. So option C is the correct answer in this. Okay, that's all the question number 20. Now you can see the question number 20 in your screen. So in that biconvex lens is cutted vertically. Okay, so let's say a biconvex is like this. Focal length of this lens is f. Here r1 is equal to plus r and this r2 is equal to minus r. Okay, or consider it as r and r. So if we determine the focal length of this lens, it will be like this: n2 minus n1 upon n1 into 1 by r1 minus 1 by r2. Okay, now if you cut it vertically, So it will be like this, R1 will become R and R2 will become infinite. So in such case, if you calculate the focal length 1 by f dash, so it will be n2 minus n1 upon n1, and in bracket it will be 1 by r minus 0, because 1 by infinite will become 0. So this will be 1 by f is equal to n2 minus n1 upon n1, and this will be 2r. This both will get added up, and this 1 by f dash will be equal to n2 minus n1 upon n1 into 1 by r only. Now taking the ratio of this two, this will be 1 by f, this will be 1 by f dash. This will get cancelled out. So here it will be 2r, and this here it will be 1 by r. So r will get cancelled out. So f dash is equal to twice of r will be the final answer. So option D is the correct answer. Okay, now let's solve the question number 21 that you can see in your screen. In that, a candle is placed at 25 centimeter from the lens. So here let's say one lens is given. Okay, so candle is placed at 25 centimeter, and on the other side the image is obtained. This is object and this is image that is obtained at 75 centimeter, and this image is obtained on screen. As it is obtained on screen, the image is real image, and that is the reason we have considered the convex lens over here. Okay, so just let's apply the formula here. U is equal to minus 25 centimeter, and V will be equal to plus 75 centimeter. So 1 by F equal to 1 by V minus 1 by U. This is lens formula. So 1 by F is equal to 1 by 75 plus 1 by 25. So this will be 1 plus 3 by 75. So F will be equal to 75 by 4. So therefore value of F will be equal to 18.75 centimeter. Okay, and clearly the lens is convex. As the image is obtained on the screen, we are having the real image, so we are having the convex lens. Let's solve the question number 22. Okay, now see in the question 22 there is one reflecting surface. Refracting surface is given. Okay, an object is placed at a distance of 15 centimeter. Here the air medium is given, and here the glass medium is given. Okay, the curvature of this refracting surface is given as 30 centimeter. Okay, the refractive index of air is 1, and refractive index for the glass is 1.5. Okay, so now we need to find the image distance. Okay, so apply the equation. So formula is, for the refracting surface, formula is n2 minus n1 upon n1, n2 minus n1 upon r is equal to n2 by v minus n1 by u. Okay, so this is our equation. See, we are having n2 n1 r, we are having the u, we are not having the v, so we need to find this v in this equation. Okay, the curvature is this side, so we are considering this as plus. So just apply. See, n2 is 1.5, n1 is 1, so divided by 30 is equal to 1.5 by v minus 1 by u. So the value of u is, object distance is negative, so u is equal to minus 15 centimeter, as it is on the left side of the refracting surface. So this will be minus 15. So therefore 0.5 upon 30 is equal to 1.5 v plus 1 by 15. Okay, so this will be equal to 1 by 60 minus 1 by 15 is equal to 1.5, and this will be v. Okay, so taking LCM as 60, 1 minus 4 is equal to 1.5 into v. So this will be minus 3. Here it will be 60, 1.5 into v. So therefore v is equal to minus of 1.5 into 20. So therefore V is equal to minus 30 centimeter. Okay. So minus 30 centimeter. This minus sign shows that image is on the left hand side. Okay. So option A is the correct one in this. In this one, option A is correct one. Let's solve the next question, question number 23, that you can see in your screen. Okay. So in the question 23, they said that prism angle is 45. On the prism, the light is incident at 45 degree. For the minimum angle of deviation, the refractive index of material of prism is √2. We need to find the angle of prism. Okay. So very interesting question is this. So incident angle is 45. Then here the said that there is a minimum angle of deviation. The refractive index of the prism is √2 and we need to find the value of A. So we are having the equation for the n, that is equal to sine A plus delta m by 2 upon sine A by 2. This is for the minimum angle of deviation. Now see, we are having 1 plus I plus E is equal to delta plus A. Now for delta is equal to delta m, we are having I is equal to E. So can we write like this, 2I is equal to delta m plus A. So therefore I is equal to delta m plus A by 2. So we can write it I over here. So the formula becomes n is equal to sine I upon sine A by 2. So this will be √2. So this will be sine 45. So we can write it as 1 by √2 sine A by 2. So taking 1 by √2 over that side, so this will be equal to, okay, sine A by 2, and this will be 1 by √2 upon √2. So this √2 will become 2. So sine A by 2 equal to 1 by 2. So sine A by 2 is equal to sine 30. So comparing the arguments, that is A by 2 equal to 30. So A is equal to 60. Okay. So this is again a important question. You should learn this one. Okay. And here option D is the correct one. Okay, now let's solve the question number 24. You can see it in your screen. Now see, in the question 24, two glass prisms are joined to form a dispersion without deviation. Okay. So let's say it is a flint glass and this is a crown glass. Now refractive index of this flint glass is given as 1.602 and here the crown glass it is given as 1.5. Now the angle of prism for this one is given as 10 degree. So we need to find the angle of prism for this one. Okay. Now formula for dispersion without deviation. Formula for the dispersion without deviation, it is like this: A2 upon A1 is equal to N1 minus 1 and N2 minus 1. So just substitute all the values. So this will be A2 by 10 and this will be 1.602 minus 1 upon 1.5 minus 1. So this will be 0.602, this will be 0.5. So therefore the value of A2 will get 10 into, solving this one you will get 1.204. So the value of A2 will be 12.04 degree because it is a degree. Okay. Now we need to convert according to the option. Now see, 1 degree is equal to 60 minutes. So 0.04 degree will be equal to how much? So clearly it will be equal to 2.4 minutes. Okay. So the value of A2 will be 12 degree and 2.4 minutes. Okay. So option A is the correct one in this one. Now let's solve the next question 25. Okay. So 25, in the question number 25, the interior incidence angle is given as 60 degree on a prism of angle 45 degree. So it means that I is equal to 60 degree and A is equal to 45 degree. It is given in the question. Now when ray of light falls on the other surface at 90 degree, the refractive index of material of prism is mu. Find the angle of deviation. Okay, we need to find the value of n and we need to find the angle delta. Okay, now see, in this the light is incident on the other surface at right angle. So it is also, there is no refraction in this case, and here the angle of incidence is 60 degree. See, it is given 45 degree and this is 90 degree. Okay, so if it is 90, this one is 45, so obviously this will be 45. And see, this is normal to the surface, and here it is also a right angle, so angle of refraction will also be 45. Okay, let's consider the material is having a refractive index n. Now see, we can apply the formula I plus E equal to delta plus A. Clearly, as there is no refraction, E will be equal to 0. So this will be 60 plus 0 is equal to delta plus 45. The value of delta will be 15 degree. Now let's calculate the refractive index. So applying Snell's law, apply the Snell's law in this. So this will be considered as n1 equal to 1. So n1 sin 60 is equal to n sin 45. So this will be 1 into root 3 by 2, and this will be n into 1 by root 2. Okay, cancelling this one as root 2. So value of n will be equal to root 3. This will be root 2. So corresponding to this, the option D is the most correct answer. That's all. The next question, question 26, that you can see in your screen. Okay, so in the question 26, it is like this. A prism is given. Okay, in question number 26, a right angle prism is given. Here it is given 45, and this is said to be isosceles prism. Now the ray is incident like this, and it is refracted like this, then again it is refracted like this. This is the path of ray that is given in the question. Okay, now you can see the ray is not coming out, it is not coming out, hence it is said to be a total internal reflection. Now see, if an angle of I is less than C, then no total internal reflection will take place, and if incident angle is greater than critical angle, total internal reflection will take place. So here, now we need to find the angle of incidence first. Now see, as it is 45, this is 90, and this is also 90. As it is 90, this will be 45, this will be 90 degree. So angle of incidence is 45. So clearly here 45 is greater than C, as TIR takes place. TIR is taking place, and that is the reason light is moving like this. Okay, so apply sign on both the sides. So this will be sin 45 is greater than sin C. So this will be equal to 1 by root 2, and applying the formula for the sin C. Sin C is equal to 1 by n. So therefore, okay, now if we apply the reciprocal, you just reciprocal this one, you need to change the inequality. So this will be root 2 less than n. So least value of n is equal to root 2, and therefore option A is the correct answer in this one. Okay. Okay, now let's solve the question number 27 that you can see in your screen. A person cannot see distinctly at a distance less than 1 meter. Okay, so person cannot see a distance within a limit of 1 meter. Okay, this region is not visible, so you cannot see the nearby things. So this defect is hypermetropia. For the hypermetropia, you need to take u is equal to minus 25 centimeter, and v is equal to this one, so that will be equal to 100 minus 100 centimeter. So apply the length formula. 1 by f equal to 1 by v minus 1 by u. So this will be 1 by minus 100 minus 1 by 100, and minus minus plus 1 by 25. So this will be minus 1 plus 4 by 100. So value of f will be equal to 100 by 3 centimeter. Okay, now if you need to calculate the power, so P is equal to 100 by f in centimeter. So this will be 100, and this will be 100 into 3. Cancelling this one, so P will be equal to plus 3 dioptray. Okay, so option A is the correct one. Now let's solve the question number 28. Now see, in the question number 28, the length of microscope is given. that is L equal to 14 centimeter. Then a magnifying power of eye is given, that is M equal to 25. Focal length is given, that is 5 centimeter, and we need to find the object distance. Okay, now see formula for the magnifying power in case of compound microscope, that is equal to V0 U0 into D upon FE is the focal length of eyepiece. Now see, this D is least distance of distinct vision, and its value is 25 centimeter. Okay, now solve. L is equal to V0 plus FE. So here L is given, that is 40. V0 is not given. F is given, that is 5. So value of V0 will be 9 centimeter. Now use this value in this one to calculate the U. So this will be 25, this will be 9, U0, this will also be 25, and this will be FE, that is 5. So this will be 5, 5, this will be 5 and 5. So U0 will be equal to 9 by 5, and that will be equal to 1.8 centimeter. Okay, so option A is the correct answer. Let's solve the next question, that is question number 29. In that, a magnifying power of simple microscope is given. So that is equal to 6. The focal length of lens in meter that we need to find out. Focal length in meter we need to calculate. Now considering D is equal to 25 centimeter, that is given. Okay, least distance of distinct vision is 25 centimeter. So for the simple microscope, the value of M is 1 plus D by F. So this will be 6 equal to 1 plus D by 25. So this will be 5 equal to D by 25. Sorry, D by, so D is 25. So this will be equal to 25 by F. Yes, so 5, F equal to 5 centimeter, and in meter it will be 0.05 meter. Okay, now let's solve the last question that you can see in your screen, the question number 30. Okay, so a person cannot see at a distance more than, this region is not visible now, but a distance more than 20 centimeter a person cannot see a things. So this defect is myopia. Okay, so in such case you need to consider U is equal to minus infinite and V is equal to this 20 centimeter. Okay, so apply the lens formula, 1 by F equal to 1 by V minus 1 by U. Okay, so this will become 0. So 1 by F equal to minus 1 by 20. So focal length will be minus 20 centimeter. Okay, and as the focal length is minus, this lens is concave lens. So option D is the correct answer. So that's all from this lecture. Okay, so keep studying hard, keep working hard, and if you are having any doubts in this ray optics, then you can mention your doubts in the comment section. So if you are really finding it helpful, please like, subscribe and share this channel. Okay, so keep working hard. Thanks a lot from this lecture. Thanks a lot. Have a great day.